From playground kickabouts to professional stadiums, rubber balls and footballs are so ubiquitous in our lives that we rarely stop to consider their origins. Yet the manufacturing processes behind these seemingly simple, spherical objects involve remarkable precision, innovative chemistry, and centuries of refinement. Whether it's a bouncy rubber ball that delights children or a regulation football that performs under the intense scrutiny of professional athletes, each sphere tells a story of human ingenuity and industrial evolution. The rubber ball, a bounce through manufacturing. The journey of a rubber ball begins not in a factory, but in nature. Natural rubber originates from the latex sap of rubber trees, primarily Hevea brasiliensis, which are cultivated in tropical regions across Southeast Asia, Africa, and South America. However, most modern rubber balls incorporate synthetic rubber compounds that offer superior consistency, durability, and performance characteristics. Raw materials and compounding. The manufacturing process starts with rubber compounding, a precise science of mixing raw rubber with various additives. Natural or synthetic rubber serves as the base polymer, but it requires numerous additional ingredients to achieve the desired properties. Sulfur acts as a vulcanizing agent, creating crosslinks between polymer chains that give rubber its elasticity and strength. Carbon black reinforces the material and provides color, while oils and plasticizers improve processing characteristics and flexibility. Antioxidants and stabilizers protect against degradation from heat, light, and oxygen exposure. These ingredients are carefully measured and mixed in industrial mixers called Banbury mixers, which use intense mechanical action and heat to create a homogeneous compound. The mixing process is critical. Improper blending results in inconsistent performance and premature failure. The compound emerges as a thick, pliable sheet that's ready for the next stage of transformation. Molding and vulcanization. For solid rubber balls, the manufacturing typically employs compression molding or injection molding techniques. In compression molding, pre-measured amounts of rubber compound are placed into heated mold cavities. The mold closes under tremendous pressure, forcing the material to conform to the spherical cavity, while heat initiates the vulcanization process. Vulcanization, discovered by Charles Goodyear in 1839, remains the magical transformation at the heart of rubber manufacturing. During this process, sulfur creates chemical bridges between rubber polymer chains, converting the soft, sticky material into a resilient, elastic solid. The temperature and duration of vulcanization are precisely controlled, typically ranging from 150 to 200 degrees Celsius for several minutes, to achieve optimal properties. For hollow rubber balls, the process differs significantly. Manufacturers often use a technique involving two hemispherical molds that are brought together with a small amount of liquid rubber or rubber paste inside. As the mold rotates and heats, the rubber coats the interior surface evenly, creating a hollow sphere with uniform wall thickness. This method, called slush molding or rotational molding, is particularly effective for producing playground balls and beach balls. Are you fascinated by the science of everyday objects? Subscribe to our channel to discover the hidden manufacturing processes behind the products you use every day. Finishing and quality control. After molding, rubber balls undergo deflashing, the removal of excess material that forms along mold seam lines. This can be done manually, through tumbling with abrasive media, or via cryogenic deflashing, where balls are frozen with liquid nitrogen and the brittle flash is removed through mechanical action. Quality control is paramount. Each batch undergoes rigorous testing for bounce height, compression resistance, and durability. A standard test involves dropping balls from a specified height and measuring the rebound percentage. Consistency across the batch indicates proper manufacturing control. Visual inspection catches surface defects, while destructive testing on sample balls reveals internal quality and compound uniformity. The football, engineering the beautiful game. While football means different things globally, soccer balls in most of the world, American footballs in the United States, both involve sophisticated manufacturing processes that have evolved dramatically over the past century. The soccer ball revolution. Traditional soccer balls consisted of leather panels hand-stitched together, creating the iconic 32-panel design introduced at the 1970 World Cup. Modern soccer ball manufacturing, however, has undergone a technological revolution that would astound early players. Contemporary soccer balls typically feature synthetic leather covers made from polyurethane (PU) or polyvinyl chloride (PVC). These materials offer superior water resistance, durability, and consistent performance compared to genuine leather, which absorbed water and became heavy during rainy matches. The manufacturing begins with large sheets of synthetic material that are die-cut into precise panel shapes. Modern designs have moved away from the traditional 32-panel construction toward thermally bonded balls with as few as 6 panels, reducing seams and creating more predictable aerodynamics. For stitched balls, skilled workers use specialized machines or hand-sewing techniques to join panels with strong polyester thread. Each seam must be perfectly tensioned. Too loose, and the ball loses its shape; too tight, and it becomes overly rigid. A single soccer ball may contain over 2,000 stitches, each contributing to the ball's structural integrity. Thermally bonded balls represent the cutting edge of soccer ball technology. Panels are precisely aligned and bonded using heat and pressure, creating seamless joints that eliminate water absorption points and provide perfectly smooth surfaces. This technology, first used in major tournaments in the 2000s, has become increasingly popular at professional levels. The bladder, the heart of the ball. Inside every quality soccer ball sits a bladder that holds air pressure and maintains shape. Bladders are manufactured from latex or butyl rubber, with each material offering distinct advantages. Latex bladders provide superior responsiveness and a softer feel but require more frequent inflation. Butyl bladders retain air pressure longer, but offer slightly less responsiveness. The bladder manufacturing process involves extruding rubber into thin sheets, cutting them to shape, and vulcanizing them into seamless spheres. A valve, typically made from brass or plastic, is integrated during manufacturing, creating the access point for inflation. After the cover panels are assembled around the bladder, the ball undergoes inflation to its specified pressure, typically 0.6 to 1.1 atmospheres for soccer balls. This inflation occurs inside a spherical mold that ensures perfect roundness and consistent dimensions. American football, a different shape. Entirely, American football manufacturing presents unique challenges due to its prolate spheroid shape. The process begins with 4 leather or synthetic leather panels that are die-cut to precise specifications. These panels are stitched together inside out, leaving one seam partially open. The ball is then turned right side out through this opening, a process requiring significant skill and specialized tools. A synthetic bladder is inserted, and the final seam is stitched closed, creating the distinctive laces that also provide grip for throwing. Quality control for footballs is exceptionally rigorous. Professional-grade balls undergo pressure testing, shape analysis, and performance evaluation. For American footballs, testing includes spiral stability and grip characteristics. Soccer balls are tested for sphericity, deviation from perfect roundness, bounce consistency, water absorption, and circumference accuracy. Want to explore more incredible manufacturing stories? Subscribe now and join thousands of curious minds uncovering the secrets of industrial production. The future of ball manufacturing. Both rubber ball and football manufacturing continue to evolve. Sustainable materials are gaining prominence, with manufacturers exploring natural rubber alternatives, recycled synthetics, and bio-based polymers. Smart ball technology, incorporating sensors that track speed, spin, and trajectory, is transitioning from novelty to mainstream. 3D printing experiments are producing custom balls with complex internal structures that would be impossible through traditional manufacturing. These innovations may eventually allow for balls precisely tuned to specific playing conditions or performance requirements. From the simple rubber playground ball to the high-tech footballs used in professional competition, each sphere represents a convergence of material science, manufacturing precision, and performance engineering. The next time you kick a ball or watch it soar through the air, you'll know the remarkable journey it took from raw materials to your hands. A journey involving chemistry, craftsmanship, and countless quality checks to ensure that perfect bounce, flight, and feel.